Hey everybody, Ripley here. Welcome back. We're going to talk a little bit about probability distribution and random variables in this chapter. This is chapter 5. And we are cruising right along. Hopefully you're starting to get in the swing of things with this classroom flipping model and aren't getting too frustrated. Remember, talk to me if you're having problems. We can figure some stuff out. All right? Let's go ahead and talk about a random variable first. All right? A random variable is simply random variable. It's a variable with numerical value. So we're talking about numbers here. All right, numerical value whose outcome is determined by chance. Is determined, or you'll hear this sometimes referred to as probabilistically. Okay, determined by chance or a certain probability. All right. Now there are two types of random variables. There are discrete random variables. So there's discrete RVs, which just like we talked about before with discrete numbers, their outcomes are going to be 0, 1, 2, 3, etc. All right, basically the whole numbers. Think of it as what you would roll on with 2 die. We're gonna actually build something by rolling 2 die here in just a sec. Excuse me. That's a discrete random variable because I roll a 2, I roll a 3, I roll an 11, I roll an 8, etc., etc. I can't roll a 7.3. Now that's going to feel a little strange when we start talking about something called expected value and means, but you'll see what I'm talking about when we get to it. And then of course there are continuous RVs. All right, and these are on a continuum. All right. An example of this would be like amount of gas I have in my car. Not in my belly, in my car. I can have, well, God, I hope not, 17.93514 gallons of gas in my car. I could have 2 pi gallons of gas in my car. In other words, it can be any number from some starting point, which in this case, excuse me, because we're talking about a ratio measurement. Remember, ratio measurement it's the highest, it's the most precise of all of the variable measurements. Okay. Remember, nominal, ordinal, interval, ratio. It would start at 0, and theoretically, if you had a really, really big car, it could go to infinity. All right. Now, what we're going to build from these is called a probability distribution. Probability. So we take these random variables and we organize them into a probability distribution. And very much like our frequency distribution, remember we've heard of distributions before, what we get is sort of a graphical account of what's going on. All right. Now, I'm going to build a probability distribution, but before we do that, I need to set the requirements for a probability distribution to be a probability distribution. And the first of these is that the sum of all of the probabilities in the distributions have to add to 1. They have to. In other words, something's got to happen. If I roll 2 die, there is a probability that's associated with every single number that I can possibly get. All right, and the sum of all of those probabilities has to be 1 because something happens when I roll die. All right. Second is these probabilities, just like all probabilities, this is sort of a superfluous one, have to be between 0 and 1. Okay, so let's do this for 2 dice. So we're going to roll 2 dice. 2 dice. All right, now let's think of the outcomes here for just a sec. All right. The possible rolls that I can get on 2 dice are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right, these are called snake eyes, those are boxcars, etc., etc. In craps, that's a really important number because after the first roll, if a 7 pops up, everybody's money gets scraped off the table. Okay, so let's think for just a sec. What is the probability of rolling a 2 with 2 die? Well, the first thing we better think about is the sample size. How big is the sample size, or what is the sample space for rolling 2 die? Well, it's going to be 6 on the first die times 6 on the second die. Okay. Now, sometimes students are like, wait a sec, Ripley, why isn't it just 12? Well, the fundamental principle of counting, since I'm rolling 2 die to make a roll, the fundamental principle of counting tells me that I have to multiply those. But an easier way to think about it is I can get a 1, 2, 3, 4, 5, 6 on the first die, a 1, 2, 3, 4, 5, 6 on the second die, and then you just match these guys up pairwise. So I can make a 1, 1, a 1, 4, a 1, 5, a 1, 6, a 2, 1. Let me change colors with this thing real quick so I can show you this, because this is kind of important. I can make a 2, 1, whoop, like that. This is where students will often say, wait, Ripley, why is the 1, 2 different from the 2 and the 1? Because they're done with different die. If you colored your die, let's say that these guys were red and these guys were green, get out of there, and these guys were green, then clearly a 1 on the red and a 2 on the green is different from a 2 on the red and a 1 on the green. So there are 36 different ways to roll. There are 36 different outcomes when I roll 2 die. Okay? Now, how can you roll a 2? Well, there's only one way to roll it. It's called snake eyes, and that's a 1 on the first. Get out of there. There's a 1 on the first and a 1 on the second. So we got 1 out of 36. All right? Now, let's figure out the probability of rolling a 7 with 2 die. All right? All right, so let's think about this. There's a 1 and a 6 and a 1, that's 2, 2 and a 5, 5 and a 2, that's 4, 3 and a 4, 4 and a 3, that's 6. There are 6 out of 36 ways, excuse me, to roll this, or 1/6. So approximately 1/6 of the time you're going to roll a 7. Approximately 1 out of 36 times. 1 in 36 times, you're going to roll a 2. Now, be careful. Remember, law of large numbers says that you have to do that a whole bunch of times to have that thing head for the value for the theoretical probability. Okay? All right, now, a probability distribution is kind of like a frequency distribution that you just flip on its head. It's easy to make. So all we do, we're going to put our x values here. Our x's are the numeric outcomes. Okay? So, oh wow, that's just horrific. Let's try that again. Sorry, again, hard to do this at your belly button when you're not looking at it. Come on now, don't be shy. Okay, there we go. And we're going to get a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And we'll pretty this up just a little bit, just so it doesn't look so terrible. All right. Now, here we go. We just figured out that the probability of rolling a 2 is 1 in 36. Now, if the probability of rolling a 2 is 1 in 36, isn't that exactly the same thing as the probability of rolling a 12? Because that's a 6 on the first and a 6 on the second. If I flip those around, I still get the same roll. So there's 1 in 36 ways to do that. All right, so let's think about a 3. I can roll a 3 by rolling a 1 and a 2, or a 2 and a 1. No other ways. It's not like I can roll a 3 and a 0 or a 4 and a negative 1. That just don't make no sense. So there are 2 out of 36 ways to do that as well. Think about an 11. Wouldn't that be exactly the same thing? 6 and a 5, 5 and a 6. So I get 2 out of 36. And then 4. Now let's think about a 4. I can get a 1 and a 3 and a 1, and a pair of 2s. There's a name for that, but I forget what it is. So 3 out of 36. 10, same thing, right? 6 and a 4, 4 and a 6, and a pair of 5s. So that's going to be 3 out of 36. You're probably starting to see the pattern, but let's go ahead and go through it. How about a 5? 1 and a 4, 4 and a 1, 2 and a 3, 3 and a 2. That's going to be 4 out of 36, which it makes sense that that's the same thing with a 9. 6, 3, 3, 6, 4, 5, 5, 4. And I end up with 4 out of 36 over here. We already did 7, but we'll get there in just a sec. 6 is 5 out of 36. Let's do 6 real quick. 1, 5, 5, 1, 4, 2, 2, 4, and a pair of 3s. So this is also, thinking about it, with 8 is going to be 5 out of 36, and then 7 out of 36. Now, if I add these up, think about that. Whoa, 7 out of 36. Where'd that come from? Ding dong. This is 6 out of 36. All right? Now, I can add these up. Let's make sure that, remember, according to our rules of a probability distribution, all of the probabilities have to sum to 1. So 3, 6, 10, 21, 30, and 36. So the sum of P of X is equal to 1. Whew, thank God.